But flip to the third sheet of paper in that composition book, and we can label these notation notes. We're going to look at a few different ways to communicate information. So we're going to be doing the same table 3 times. So if you want to pause the video and go ahead and sketch out this table 3 times, you don't need a whole lot of room in each box. Maybe like 2 lines for each box. So you can go ahead and pause the video and draw your tables. Okay, so hopefully you're already a little bit familiar with these notations after doing the card activity. So look, we're going to start with a verbal description. So let's take this verbal description. B is at least 30. And we're going to translate that into 4 different formats. B is at least 30. Okay, so interval notation, we're going to do the smallest value, comma, the largest value. So we're going to start with the smallest value and go to the largest value. So if B is at least 30, the smallest it could be is 30. For going bigger than 30, we can keep going to 35, 70, 491. We can keep going forever. 1,000,000 is at least 30. We're going to head toward infinity. If B is at least 30, it's 30 or greater, so it could equal 30. So we're going to put a bracket on there denoting that it can be equal to 30. Okay, let's go ahead and do the number line first before we do the inequality and set notation, because I think it gives us a nice picture of what's happening. So on our number line, we don't need a whole lot of numbers. Let's just put like 29, 30, 31. Usually when you've drawn number lines in the past, you probably had 0 on there. 0's on this number line. We just can't see it on the part that I've written. So I'm going to change colors here. You don't need to change colors in your notes if you don't want to, but you can change colors to a highlighter or colored pencil or colored pen if you want. Okay, so since B can equal 30, on the 30, I'm going to put a closed circle. It can be anything greater than 30, so we're going to shade this number line to the right. And I'm going to put a closed-in arrow to show that it keeps going forever. An option is if you instead would prefer to do a double arrow, that means the same as the closed-in arrow, which means going on forever. Okay, our inequality, well, these are all the B values. They are greater than or equal to 30. Usually whenever you have a greater than or equal to, that's going to translate, or that's going to result from a bracket over here in interval notation. The equal to means bracket, just like that underscore means equal to. Okay, set notation is just like inequality, but it's got a little extra notation. So we're going to use a squiggly bracket, B such that B is greater than or equal to 30. This vertical line segment is shorthand for such that. B such that B is greater than or equal to 30. Okay, so important thing in Algebra 2 is communicating mathematically. So that's going to be important the rest of your life. You will have to communicate in math, even if it's just like with numbers and measurements. You'll be or dollar amounts. You'll be communicating with math the rest of your life. But these are just several different ways we can communicate the same information. Okay, so let's try this one. A is greater than 5, but no more than 10. A is greater than 5, but it's no more than 10. So the 5 and the 10 are surely going to be important in this problem. go ahead and make our number line, and let's just number from 4 to 11. Okay, so if A is greater than 5, it doesn't say equal to 5, it just says greater than. So that means I'm going to go here on the 5, and I'm going to put an open circle. Since it's not equal to, it's just greater than. And I'm going to start shading to the right. But what else does it say about A? It's no more than 10. Can it equal 10? Yes, 10 would be no more than 10. So it can equal 10. It just couldn't be 11 because 11 is more than 10. It says it can be no more than 10. So it can equal 10, so we're going to put a closed circle there. Okay, let's take this number line now and translate the information into our other notation. So the smallest in the shaded region is 5. The largest part of the shaded region is 10. On the 5, we're going to put a parenthesis, because that correlates to the open circle. It does not quite equal 5, but very, 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 very close. How close? Super close. Closer than you can even imagine, but not quite 5. And since we're equaling 10, we're going to put a bracket here. Okay, let's go ahead and do our inequality. So do you see where the shading is? The shading occurs between 5 and 10 mostly. So I'm going to put an A there to show that A comes between 5 and 10. So whenever you're shading between two values and your graph looks like a line segment, you're going to put the A between those two values. And you always put less than symbols because we're reading from a smaller number to a larger number. So we're putting less than symbols. Now the question is, do either of these get an underscore? Yeah, we're going to put an underscore here because it can equal 10. Then going to our set notation, we're just going to put A such that, and then we just copy this inequality expression over. 5 is less than A is less than or equal to 10. Okay, and one more. For our third example, we're going to say J is less than 4 or greater than 8. J is less than 4 or greater than 8. So let's start a number line. So let's number from 3 to 9. You don't have to number every single number as long as we can get a sense of what the scale is on the line. That's sufficient. So changing color again. I'm going to go to the 4 and put an open circle because it doesn't say less than or equal to, it just says less than. And let's just pay attention to that part of it first. If J is less than 4, it's going to be from 4 to the left side of the number line forever. J is less than 4. Or J is greater than 8. So we're going to go over here to 8, put an open circle again because it doesn't say anything about being equal to, and we're going to shade to the right forever. Okay, so for our interval notation, we have 2 different intervals shaded on the graph, so we're going to have 2 different intervals to write down in this box. So the first interval, it goes to 4 for its biggest value, or not quite 4, but almost. So I'm going to put this parenthesis. The parenthesis means very, very close to 4. How close? Closer than you can even imagine. Super, super close, like 3.9999999999999, not quite 4. And then we're shading it to the left forever. So would this shading go at least to -1? Yeah. Would it go at least to -50? Yes. This shading on the left would keep going forever to the left, and it would approach negative infinity. If it helps you, by the number line, you can put a negative infinity there to show that going left forever would approach negative infinity. Now, infinity is an idea. It's not really a number. So you can't ever get there. You can just get close to it. That's why we're always going to use a parenthesis on an infinity or negative infinity, because we can never actually get there. We're going to do a big U. So if you're ever typing this in on a computer, which you will be, make sure you use a capital U. That U stands for union. It's the union of two intervals. Okay, the second interval starts a little bit bigger than 8. Not quite 8. That's why we're going to use the parenthesis. A little bit bigger than 8, and it's going to go to the right forever, so it's going to go to infinity. Okay, just like we had two intervals, we're going to have two inequalities. So the first inequality, these were x values that were shaded that were less than 4. Oops, and we're not talking about x in this problem, we're talking about j. J is less than 4, or j is greater than 8. And the inequality is basically translating the verbal description straight to the inequality. So our set notation, we're going to have j such that j is less than 4 or j is greater than 8.